hydrogen peroxide and the oxalate ester triggers a series of chemical reactions until eventually we have something called a cyclic peroxy compound. This compound decomposes, breaking apart and giving us carbon dioxide and sending the atoms of our solution to a higher energy level. In order for those atoms to return to their natural energy level, that excess energy has to be released. In this case, it's released in the form of light. Now, chemiluminescence...
And finally, with really weird wand shapes, like these 3D geometric wands, we can explore some insane soap film surface tension in action as the films minimize their surfaces in a battle between air pressure and tension from so many directions.
When we add the aluminum can, it instantly reacts with the sodium hydroxide solution, forming sodium aluminate and hydrogen gas. This might take a while, so let's speed things up. Let's take a look and see if the soda is still in place. The aluminum can has mostly dissolved in the sodium hydroxide solution, but we're left behind with this. This is a thin plastic lining that coats the inside of our beverage cans. But why is it there?
And that's where this comes in. This is McWane's patented state-of-the-art pencil launcher. Pencil already in the chamber, connected to an air compressor loaded to over 100 psi, aimed directly at our target. That's a lot of power for a little pencil. Here we go. In 3, 2, 1...